Okay, so for this problem, suppose a jar contains five red marbles and 20 blue marbles. If you reach in the jar and pull out 2 marbles at random, find the probability that both are red. And so you're pulling 2 at random, which means you're not replacing, which changes the number of marbles. But we wanted the probability both are red. So when we pull the first one, the probability the first one is red is 5 out of the 25, because there's 25 marbles. There's 5 red and 20 blue. Make them. So 5 out of 25. This first one. Right here. This is the first one red. Now when I pull that, because I'm not putting it back in, it changes how many marbles are in there. Now, because I pulled a red, there's 4 red and 20 blue. So there's only 24 marbles. So when you do the second one, there's 4 red out of the 24. So that's how I got 4 out of 24. So the first one, there was 5 red out of 25. Because I didn't put the marble back, it changed the probability, so there's 4 out of 24. I reduced them first instead of trying to multiply. 5 over 25, divide top and bottom by 5, you get 1/5. And 4 out of 24, you can divide 4 and 24 by 4 to get 1/6. Because the answer had said, write your answer in reduced fraction. And then multiplying across, 1/30. So the probability both are red is 1/30. The second problem I made a contingency table just so we could have the totals and see it a little easier. Because they said a pollster contacts 102 people, so that's our total here, 102 in the age range 18 to 21, and 87 responded and 15 refused. And then he contacted 285 people in the 22 to 29 range, 258 responded, 27 refused. And then I counted the total so that adding down, this is the total that responded, and this is the total that refused. And this is the total number of people, which they did say we're pulling 1 of 387 people at random. We want to find the probability. Choose 1 at random, probability 18 to 21, or respond. Now, when we're doing an OR, there's a formula. For the probability of A or B, you take the probability of the first one plus the probability of the second one, but then you have to subtract the probability of the two together. Because if I took the probability 18 to 21, that would be going across here. But then I want the ones that responded, which goes down. Notice that I'm adding that 87 twice, because going across it's in the 102, going down it's here. And so you have to subtract that overlap. So to find the probability 18 to 21 or respond, we find the probability 18 to 21 plus the probability they responded minus the overlap. So the probability 18 to 21, 102 out of the 387. That's the first fraction. The second one is the probability they responded, which is 345, because that's this column, out of the 387. Then we need to subtract the overlap. Age 18 to 21 and responded is this one here. And so that would be 87 out of the 387. When you combine those, you get 360 out of 387. And they wanted the answer as a percent, rounded 1 decimal place. So I multiplied by 100 to make it a percent. And I got, the reason I didn't put the decimal, because it said 1 decimal place, it was a 0. It was 93.0.